Okay, let's continue. Again, we're determining if the function is 1-to-1, and if so, find the inverse. So let's look at f of x equals x squared plus 2. As a reminder, x squared plus 2 is a regular parabola moved up 2. Now, if you look at this picture, what you notice is that it fails the horizontal line test, which means that it's not 1-to-1. Functions that are not 1-to-1 do not have inverses that are functions without domain restrictions. For example, if I took only half of x squared, I could do it. But in our case, there is no inverse. No inverse for that combo of domain and range. F of x equals 8 times x minus 2 cubed. Okay, x minus, this is also constantly increasing. But if we want to use our other strategy, f of a equals f of b strategy, the one we use for equations, 8 times a minus 2 cubed equals 8 times b minus 2 cubed. Divide by 8, so a minus 2 cubed equals b minus 2 cubed. Take the cube root of both sides. Get a minus 2 equals b minus 2. We don't have the plus or minus in this case because it's an odd root, and add 2, so a equals b. So this proves that this thing is a 1-to-1 function, so we can use our strategy. Y equals 8 times x minus 2 cubed. It's x equals 8 times y minus 2 cubed. Now we divide by 8. X over 8 equals y minus 2 cubed. Take the cube root. So now this is the cube root of x. The cube root of 8 is 2 equals y minus 2. And add 2. So we have 1/2 times the cube root of x plus 2. So y equals 1/2 the cube root of x plus 2, but we turn the y back into an f inverse of x. So the inverse of a cubic is a cube root, which makes sense. They're inverse operations. Linears have reciprocals, which is why the slope between our linears were reciprocals in the past. Now let's look at what happens with a rational, because this strategy is a little bit trickier with a rational. I didn't ask you to check that it's capable of having an inverse. I just asked you to find the inverse. So if we have y equals 2x minus 3 over x minus 4, if I switch the x and y's, I'm now going to have 2 y's. 2y minus 3 over y minus 4. So to solve for y, I'm just going to clear the denominators. We know y can't be 4. We knew x couldn't be 4 before. So multiply by y minus 4 on both sides. So we get xy minus 4x equals 2y minus 3. In order to solve for y, I need to get all my y terms to one side and everything else to the other side. So I'll move the 2y to the left and the 4x to the right. Xy minus 2y equals 4x plus 3. Factor out the y. These share y. I can factor it out. Y times x minus 2 is 4x plus 3. And then divide by x minus 2. So y equals 4x plus 3 over x minus 2. So this is my inverse. So f inverse of x equals 4x plus 3 over x minus 2. And one thing you'll notice, if you remember back to the rationals at the end of chapter 3, here x couldn't be 4 because x equals 4 is a vertical asymptote. Our horizontal asymptote here was y equals 2. Because it's an x equals line and a y equals line, in your inverse, they're actually backwards. X equals 2 is now our vertical asymptote, and y equals 4 is our horizontal asymptote. That's something you can actually use to kind of guide you, knowing that those types of asymptotes are going to switch, because those have a pronounced effect on what our equation looks like. Some people might notice that the only thing that happened here was these two numbers switched places, but that's not really necessarily true. You kind of have to understand what's happening with the asymptotes in order for that to be the case, because there will be some issues with signs if all you do is switch those two. Now, if you're graphing the inverse of a function, you take the points that you see and you reflect them across the y equals x line, which is also switching the x and y coordinates. So here we have the typical square root of x function, which means we have the points 0, 0, 1, 1, 4, 2, and 9, 3. So for our inverse, we take those points and we switch the x and y. So still 0, 0, still 1, 1, but 2, 4, and 3, 9. So if we plot those, 2, 4, 3, 9. Instead of curving to the right, it looks like it's now curving up because it's a reflection across that line. Because x and y's are changing, positive in the x direction is right, positive in the y direction is up. Everything going up and right, flip. Everything going down and left, flip. And if you're confused by that idea, you can always reflect just the points. So if we look at some shapes on the next page, it's not too difficult to reflect them. We'll do a few of these. Let's look at the line on number 2. So example, it goes through the point here. Looks like 9, 9 up there. Since it's a line, we only really need one more. It looks like we have the point 6, 0. I can reflect 6, 0 to 0, 6. 9, 9 is still 9, 9. But again, to connect a line, remember you only need 2 points. So this should be enough for us to make it through. We should have 3 and negative 9 as well, it looks like. These are inverses, and again, if we look at that symmetry line through the center, it does look like a reflection across that line. For more awkward shapes, the strategy still holds. Let's just make a note of some of the points we have on the original. So on the original, it looks like we have negative 10, negative 9, negative 8, negative 1, negative 3, negative 1, 0, 1, 1, 3, and 6, 4. So of course, for our inverse, we'll take those and flip them. So negative 9, negative 10, negative 1, negative 8, negative 1, negative 3, now 1, 0, 3, 1, and then 4, 6. And then we just connect them. Looks kind of like a pair of tongs. But again, if you wanted to look at this through the idea of symmetry, if we draw this line through the middle, they are a reflection across that. So that's really all there is to 4.1, and we'll continue with 4.2 in the next video.